Hello, this is our first example on trigonometry. With trigonometry, the first thing you have to do is identify exactly where the right angle is. And the right angle is here, so the side that the right angle points towards is the hypotenuse, and that's always the longest side. Okay, so we'll label that as the hypotenuse. And then one angle is always going to be labeled, in this case theta. It can be labeled as anything, A, B, X, Y, it doesn't matter. But whatever angle is labeled, if you draw a little arrow pointing away from that angle, okay, so draw a little line, a little arrow pointing away from the labeled angle, the side that it points towards, we're going to label that the opposite. Okay, and then the third side, so we've got the hypotenuse and the opposite, the third side, this one in this case is the one along the bottom, we label the adjacent. Okay, and I would encourage you, anytime you're doing a right triangle trigonometric problem, to label your three sides before you start. So begin with the hypotenuse, it's the longest side opposite the right angle, and then whatever angle is labeled, the side that facing away from that is the opposite, and the third side is the adjacent. So in this case we know that the hypotenuse is 10 and the adjacent is 8. Okay, so what we're asked to do, use the Pythagorean theorem, h squared equals a squared plus b squared, to find the missing side in the triangle below. Now you may have seen the Pythagorean theorem written with c squared equals a squared plus b squared. The letters don't matter. I use h because it stands for the hypotenuse. So if we do that, h squared equals a squared plus b squared. H is 10, the hypotenuse, and the other two don't matter. A and b can be the opposite and the adjacent. It really doesn't matter at all. So let's say the opposite, we'll call this x. Okay, so the opposite is x, so x squared plus 8 squared. Okay, you've used Pythagoras' theorem often enough to know the only important thing about Pythagoras' theorem is that you put the hypotenuse on its own. So this is 100 is equal to x squared. 8 squared is 64. So if we want to get the x squared on its own, take away the 64. 100 minus 64 equals x squared. So 36 equals x squared. And remember, if we have an equation in x squared, then we take plus or minus the square root of the other side to give us x. So square roots get rid of the square. But since we're talking here about the length of the side of a triangle, minus answer makes no sense at all, a negative answer makes no sense at all. So we forget about the minus because of the context of this problem, and we say the answer is just the square root of 36, which is 6. So 6 is x. Okay, so that's the first part of this problem done. Okay, and now we know the three sides. So now what we have to do is evaluate each of the 6 trigonometric ratios. So the 6 trigonometric ratios are going to be sine of theta, cosine of theta, which we already know. We already know that that's 8 over 10, so we don't need to do any more work on that one. Sine, cosine, tan of theta, cosecant theta, what else? Secant theta, and cotan theta. Okay, so those are the 6 ratios. Now the ones that are obviously well, maybe it's not obvious, but it will become obvious. The ones that are most important are sine, cosine, and tan of theta. Okay, so sine of theta, sine is, if you remember, SOHCAHTOA. Okay, if you remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So sine of theta is opposite over hypotenuse. So the opposite here is 6, opposite over the hypotenuse, 6 over 10. Okay, now again, if we want to, we can break that down. And 6 over 10, if you divide top and bottom by 3, could be 3/5. Cosine of theta, we know it's 8 over 10. If you want to simplify it, it's 4 over 5. Tan of theta is opposite over adjacent. So opposite over adjacent, and that in this case is 6 over 8 or 3 over 4. And you should always simplify fractions. Cosecant theta is the reciprocal of sine theta. Okay? It's the reciprocal of sine theta. So you look at sine theta, which was 3 over 5, and the reciprocal of that is 5 over 3. Okay, so you just look at sine theta here, and you turn it upside down. Secant theta is the reciprocal of cosine theta, so it's 1 over cosine theta. So you look at cosine theta here, and you turn that upside down, you get 5 over 4. And cotan of theta is the reciprocal of tan theta. Okay, so 4 over 3. Okay, so these relationships here are very important and need to be learned off. Now, they are not as important right now as sine theta, cosine theta, and tan theta. And I actually didn't write this one down. I should have written it down. Sorry, I forgot about that. So, cotan theta is 1 over tan theta. Okay, so those relationships are important as well. These are the main relationships you need to worry about. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tan of theta is opposite over adjacent. Okay, so you do have to go and learn those off. But those are the answers. First of all, we've used Pythagoras' theorem to find the missing side, and once we had all 3 sides, we were then able to write down sine of theta, cosine theta, tan theta, cosecant theta, secant theta, and cotan theta.